Alright, hello everyone, this is Mr. Crozier, and I want to give you some help on some Chapter 4 review problems. We're doing problems 5 through 10. I'm not going to give you the answers here, but I am going to get you started on all of them. Alright, number 5 says we have a function and we want to find the derivative's value at 0. Well, we just take the derivative of this, and it's going to involve the chain rule and some logarithm rules and some exponential rules. So I could just say that the first derivative is 1 over this whole thing. Remember, we keep this the same. And then what do? Well, we multiply it by the natural log of the base, which would just be the ln of e, which is 1. Then we multiply it by the derivative of this top thing. And what is the derivative of the top right here? I'm going to write it separately. And the derivative of the top would be 1 plus 0 plus e to the x always stays the same. But wait a minute, it's not e to the x, it's e to the negative 3. So we have to tack on this chain rule there. So we have the first part, second part, and the little chain rule that goes with this one. This is the big chain rule that goes with this one. That's the chain rule that goes with that one. Alright, that'll set your derivative up. Plug in 0. You should be able to find the answer. On the next one, it's just a straightforward derivative, dr d theta. It's just asking the same thing as what if those were x's and y's. Alright, number 7, pretty straightforward here. Take the derivative, I'll get you started, right? It'd be 3y squared times the chain rule of that. The derivative of y would be dy dx. And you can finish it when you get it done. Plug in this point, and the point has an x-coordinate and a y-coordinate. Remember, when we're solving derivatives like this, your solution will be a fraction with an x and y both in there. Number 8, use a calculator. This is a calculator problem, so you can just go to the math type right there, and if you can type it in correctly, you'll have the correct answer there. And then write your answer in a sentence. You don't need to show any work. You can just go ahead and write it down. Give your answer in a sentence. Number 9. When is the slope of the function equal to 9? Well, find this derivative. And we just got done doing a natural log one up here. Same thing here. But what's going to happen is you're going to wind up with a spot where you have to put dy dx is equal to, we have our derivative over here, and we're going to put the slope is equal to 9. So you will get the function over here, the derivative, equal to 9. Solve the equation. Hint, there's several ways to solve this. I wound up with this spot where I had a proportion, and to solve the proportion I just cross multiplied and said a times d is equal to b times c. There's other ways to do it, but that's how I did it. Find the exact value, write it out with the logarithms included, then round to hundredths. Alright, on the second one here, find the second derivative. Well, you should know what the derivative of inverse tangent is. Don't forget to use the chain rule there. And hint on this one, you're going to wind up with something where it says y dy dx is equal to something over another quantity. And you could use the quotient rule, but when I'm in this situation, I mean, I find it easiest just to say this is a times b to the negative 1. And then you could use the product rule or the power rule. I mean, if this is a constant, you could just use the power rule. If a was 3b to the negative 1, you could use the power rule right there instead of the product rule. Alright, I hope this helps.